check, good. So I'm Max Ceron, CWB Association Welding podcast. Today we have a really cool guest, Welding podcast.
The show is about to begin.
Welcome to another edition of the CWB Association podcast. I'm Max Ceron with you as always here to talk again with some more crazy, interesting minds out there in the welding and steel trades world. On today's edition, we're going to be talking about robotics, and Yaskawa and Tyler Rudnicki is here with us to tell us about this whole crazy world of robots. And Tyler, how you doing?
Pretty good. How about you?
I'm doing awesome. It's a crazy day on the news today. I've been glued to the news. I don't know when this is going to air, but today is the election day in the U.S. So.
Oh yeah, there's lots of information floating around. Tons of people saying go vote all over Facebook and Instagram.
Yeah, so it's a big deal down there. So that's kept me pretty in tune today. Lots of stuff going on in the world. And you know, how are you doing? You're out in Ontario, aren't you?
Yeah, so I'm in Guelph, Ontario. About 45 minutes from Toronto.
Awesome. One of my best friends in college was from Guelph, Ontario, which I always thought was interesting because Ontario's got so many great universities. And then when you meet someone from Ontario who's taking a university program in Regina, it's like, what are you doing here? But I shouldn't say that. The U of R's got some great programs that we're known for, I guess. Just slanging my own alma mater there. Sorry. Sorry, U of R. But so, Tyler, you look pretty young. How old are you?
I'm 24.
24 years old. So
Yeah.
you've been bouncing around already a bit on your trek here. Like you went to school in Guelph, in high school there?
No, actually, I'm from Thunder Bay, Ontario
Okay.
originally.
So that's smaller.
So I came down to Southern Ontario. People like to call it Central Ontario. Down towards Toronto for school.
Hmm.
And I went to Conestoga College.
And see, Conestoga is, I never heard of it as a Westerner until I got involved with CWB. And there's lots of involvement between that college and the CWB, and you know, generally lots of involvement with the welding world across Canada. Lots of grads out of that college.
Mhm.
So before you went to college, let's backtrack into baby Tyler's life. You know, did you see yourself heading in the way of the hands-on world of building? Because if you're an engineer, you're dreaming about building things, right? Did you see yourself as on the floor creating cool things, or did you look at yourself more on the academic side, like you wanted to be an engineer and just kind of sit behind a desk? Kind of where did you see your path going?
Yeah, it was always a challenge for me because I knew from a very young age that I liked building things and being hands-on. I worked on snow machines and ATVs and cars and trucks all through my younger years and through high school. So I really liked being hands-on, but I was always told by family and by guidance counselors and teachers that because I was capable in math and science that I should be striving higher than just being a hands-on person. Whether that's mechanic, which is kind of the thought process that I was thinking in high school,
Hmm.
or going into mechanical engineering. That was kind of the what I was torn between, and it always felt like personally I was thinking more hands-on, but parents and guidance counselors and teachers kept saying, well, no, you don't want to do something like that. You have so much more potential than that. So it was always this weird feeling of not really sure what I should be doing and how I can blend what I want to be doing with what other people think I should be doing.
There's a big divide in the world. Like I grew up in a tradesperson house, but I did really well in school. So it was always like you got to go to university and hammer that out, whatever that is that you see yourself doing. Which at 17, like you don't know what you see yourself doing. You just know what you like to do at that moment. Which for me at that time was cars. I loved building cars and working on cars, modifying cars. So my likes went towards building, same as you. I think that that's a huge disservice that society does to kids coming up. And I will tell you that I have sent programs to high school counselors, and they have not giving it to the students because the counselors themselves are saying, no, I'm not even going to give the kids these options. I'm going to push the university programs. And I've always wondered if there's some kickback program or something crooked going on there. Because, like, I mean, how can you not? If you look at your class, like, how big was your graduating class?
From high school.
Yeah, from your school.
It was about 300 people. We were one of the larger high schools.
Okay, so you got 300 people coming out of high school. How many of them do you think went in the trades, and then how many do you think went to university? I know it's a broad question, but just roughly.
Yeah, I mean, it was definitely a very solid line during graduation
Mm-hmm.
of the group that walked across going to university, and I would say that was probably 75,
Yeah, well, me
at
too.
least 75%. And then there was a small group, maybe say 5 to 10% that were going to college. And then everyone else was, I haven't decided. I'm not sure what I'm doing in life. I'm just going to take a few years, travel, try some jobs, that kind of stuff.
Yeah, and now they're like making patchouli deodorant in their sink at home. Like, no, like it's a different thing. I went to university, but then I came back to the trades because I just wasn't finding what I was looking for. So you came out of high school then, and you decided to go to university first. What was your, or did you go to a college, or what was your angle?
Yeah, so I actually applied to a bunch of mechanical engineering programs. Um, with the mindset all the way through high school, especially in my grade 11, 12 years, that my guidance counselor said that my grades were appropriate to go into mechanical engineering, and that's where I should be setting my sights. So that's exactly what I did. I followed what I was told. I applied to mechanical engineering programs. And then very late in grade 12, I actually qualified for the national skills competition for automotive technology, which was kind of something that I was doing in high school as like a side option, but
Hmm.
wasn't really putting too much thought into. And that kind of opened my eyes to what was available through the colleges. It wasn't just a very simple, you're going to be a mechanic or you're going to be a production welder running the same part over and over again. There was so much more to the trades and so many more opportunities that actually I ended up applying to Conestoga College after the acceptance deadline because that really opened my eyes that much that I was just like, you know what, I need to explore this option
Go
because it's
check it
really
out.
appealing
Yeah.
to me. Yeah.
Now, so you went to Conestoga then instead of going to a university for mechanical engineering?
Yeah, that's right.
Did you, or does Conus, because I don't know how the setup is there, I just know how it is at my college. Did the program you signed up for have kind of like a sister university program where you could take your course at Conestoga, and then if you decided to go into engineering down the road, they would take some of your courses and give them credit?
There was no official partnership. Our teachers did let us know of a couple opportunities at different universities that would take a varying amount of our courses.
Hmm.
Um, it's unique in that we actually graduated as manufacturing engineering technologists. So it was difficult to kind of fit our programs into a traditional mechanical engineering or industrial engineering, which are the more common university courses.
Yeah.
We kind of floated in between those two.
Yeah, we're having the same problem. We have a manufacturing course that I help design and teach here at the college, and Saskatchewan's a little late coming to the party in one way is that we didn't have the manufacturing program set up here, but on the other hand, Saskatchewan is very deep into manufacturing. We have huge manufacturing plants here in Saskatchewan, and kind of it was like the rough and tumble wild west of how you got your education. Right before we went live, we were talking about how difficult it is for young people now to come up because the older generations are kind of holding on to information for dear life and not really sharing some of the really key insights to tricks to design that you only get from experience. You can learn a lot of theory in college, but the design, shortcuts that you get from actually building things and having them fail is something that you only get through experience, and that's tough. You as a young person, did you find that you had access to mentorship in the college? Like, did you feel well supported?
Yeah, our college was fantastic. We had a ton of very knowledgeable people, and the structure of the program made it very easy to kind of find your way and find your group. Um, So our program was structured in that the first year was a common core with a welding techniques program. So we were hands on in the booths, burning rod day in and day out. Um, and then we kind of progressed on further than that into the robotics aspects, the more engineering concepts and design work. So you could kind of find your niche with different professors and different teachers and some of the teaching assistants, the other people that were in the college and available.
Yeah, and then at that point, you're how long is the course? 2 or 3 years?
It was a 3-year program.
So a 3 year program. You're doing your first year now. It feels like you loved it, so you're probably having fun. Where did you find yourself gravitating towards when you're talking about people breaking off into their groups?
Yeah, it was interesting. We all knew that who was signed up for the 1-year techniques program, who was signed up for the 2-year welder fabricator program, who was signed up for the 3-year technology program, who was in the robotics stream, who was in the inspection stream. So we all kind of knew where we all were, and it sort of broke into those groups a little bit from the beginning. But you also kind of found those people who were really interested in a specific portion of the welding industry. So there's kind of like a little subgroup that was really into metallurgy, and then there was
Hmm.
another little subgroup that really got into the robotics side. So you could kind of find those little niches. For me, it was more in the metallurgy portion. I really found that interesting. So I kind of gravitated towards that group.
And that's cool because I love metallurgy. I don't know if you've seen the videos I made, but I live and breathe it, and I swear, it's made me the better tradesperson than someone who has a less understanding of metallurgy. Really knowing what's happening at a atomic level in the materials you're working with is so helpful. It's
For
like
sure,
it's
for
like
sure.
having 3D vision inside the material. You know what I mean? Like,
Yeah,
so
definitely.
you came out of college. You squeaked your way through because I'm sure it was really hard, and you don't want to make it sound too easy for the people out there. And and then, did you have trouble finding work? Did you get hired right away?
No, there wasn't a big issue. Our program's very lucky in that the majority of our grads get job offers before they graduate. So I was in the same situation. I had a couple different offers, but I wasn't really sure. There was nothing that jumped out at me. There wasn't really that metallurgy niche that I was really interested in. There wasn't really an opportunity to go into some job that was like, wow, this is the one for me.
Yeah, like I know
Um,
that job exists because I've seen the guy who has that job, and I've always been like, wow, how did you get that job? Like designing wire filler materials, designing
mhm,
filler materials for large electrode companies. That's the metallurgy guy. You know what I mean? That's that
yeah.
niche job.
Yeah, so I, I didn't really have that opportunity. I had lots of different opportunities, but nothing that really jumped out at me. So I had a few different interviews, and I eventually landed with Air Liquide
Hmm.
in one of their sales positions in one of the storefronts. So that was where I originally went after college.
Did you feel like you were comfortable in that position? Did you feel like that's where you should be, or like, I mean, being a sales guy for a welding supplier, there's a ton of knowledge you're going to have to ingest on products and
Mhm.
products abilities and the specifications of products. I'm sure that's a learning curve in itself.
Yeah, definitely. It was a very interesting job. They carried a ton of different products from a ton of different suppliers and manufacturers, and the area that the store that I was in was very diverse. You had everything from the small mom and pop shops that were doing heavy equipment repair on farm equipment, all the way up to the tier 2 automotive company that was around the corner.
Hmm.
So you had quite a diverse customer base, and it was always interesting to hear and try and work with the people to solve the problems that they were having and try and figure out what product was right for them.
Yeah, one of the directors on our CWA Association here in Regina, Chase. Shout out to Chase from Air Liquide. We were talking about that one day, and he's like, it's almost like the sales guy for welding shops in town has the real pulse of what's happening in the industry. He really knows more than anybody which shops are doing well, which ones aren't, who's got new programs, who's on the R&D side, who's playing with different mixtures, who's playing with different machines, and then who's not, who's kind of just sitting on their laurels. And And I thought about that, and I was like, yeah. And he's a red seal welder who now works for Air Liquide, and he takes that into it. So that's cool. How long were you there for?
I was only there for the summer,
Hmm.
and then I was approached by a company who sells CNC software as well as robot programming software.
Which company? Can you
Um,
say?
yeah, that was In-House Solutions.
Okay.
They're the supplier for Mastercam throughout Canada, and then the robot programming software is called Octopus.
And Octopus has been they've been pushing pretty hard their software suite for the last few years. It's kind of like it's what is it? It basically allows different machines to speak to each other, right?
Yeah, it's basically like you have one uniform interface to program all your different robots, whether it's a blue one, a yellow one, an orange one, doesn't
Yeah.
matter. They're all programmed the same way in the software, and then the software does like the converting basically.
Yeah.
The same idea as what Mastercam does for different CNC machines.
I think Radan is also in that game too for brake presses and stuff like that. So,
Yeah.
all right. So then, how long were you at In-House Solutions?
Yeah, so that one was, I was actually in the educational sales position for a little while. So that was about 6 months there, where I was responsible for sales into the universities, colleges, high schools in all of Canada.
That's fun.
Um, and then the gentleman who was actually selling just Octopus into the industrial customers decided to move on to another opportunity, and I was able to fill his shoes. Um, at which point, the company also decided to kind of reorganize and take all the Octopus people and put them in the Octopus office, which was actually one city away.
Did you go?
I did, yeah. So I went, I went to the Octopus office very shortly after I was done in the educational sales position.
Okay, yeah. I had
And
to ask because
there,
sometimes people are
yeah,
like, move, screw that. I'm not
yeah,
going nowhere.
yeah. No, it was in Southern Ontario. One city over is another 15 minutes of commute, so
It
it
doesn't
wasn't a
matter.
big deal for
Yeah.
me. Yeah, so when I got there, I was responsible for Ontario, Manitoba, Saskatchewan, and then shortly thereafter grew that into the rest of Canada, and then took over Michigan for a little while, sold into Mexico for a little while, which was pretty interesting.
Awesome. And then you did that. So now you're getting contacts across the country. Now you're getting onto the industrial, product side from a specific person or company, which is you're starting to hone in your career because that's kind of usually how it goes.
Mhm.
And then from there, how long were you at working in in-house, and then from there, where did you go? Or from Octopus, I
Yeah,
guess.
so I was with Octopus for a year. Where I really made a point of working with the robot OEMs, which was a really good opportunity for the company. But it also worked out to build a lot of connections to some of the robot techs that worked for the various companies, the salespeople, the engineering managers, all those different higher level connections at the robot OEMs.
And then from there, that got you into where you are now.
That's exactly what happened.
Oh, so
So working with,
did you get poached? Did someone show up and say, Psst, meet me in the parking lot?
not exactly like that, but something similar. Yeah. Yeah, one of Yaskawa was actually one of my customers at the time, and I was having a lunch with the engineering manager, and he said, "Hey, do you know anybody that would be interested in this job? It's pretty interesting. It has this role and these responsibilities. Uh, Ask around in your network and see if there's anybody that would be interested." And
And
turned
you
out
were
I was
like,
interested.
you're like me,
Yeah.
take me. And is that where did you have to move again for that job, or was that still where you were at the in with Octopus?
Yeah, I continued to live in Guelph, so it was a bit longer commute because the Yaskawa Motorman office is in Mississauga, so going back towards Toronto.
Hmm.
So it was a bit longer of a commute, but I got to live where I was currently living. Yeah.
Well, that's good. All right. Well, we're at the halfway mark. This is now the recap of young Tyler Rudnicki's life, and we're right to the point where I wanted to now get into the talk about what's going on with his current job. So stay tuned here with the CWB Association podcast. I'm Max. This is Tyler, and we'll be right back after the short break.
The CWB Group is Canada's national welding certification organization. We're pleased to offer welder testing at our state-of-the-art facility in Nisku. We provide welders the opportunity to practice for and take a CSA W47.1 welder qualification test. Book your welder qualification test with Canada's welding experts. Give us a call today at 1-800-844-6790 or visit us online at cwbgroup.org to book your training or testing slot. The CWB Group. We are welding.
The CWB Association membership is new, improved, and focused on you. The CWB Association is offering a free membership with a full suite of benefits to anyone interested in joining an association that is passionate about welding. Build your career, stay informed, and support the Canadian welding industry. Become a member today. Register at cwbassociation.org.
All right, I'm back here on the CWB Association podcast. My name is Max Ceron. Thanks for tuning in. Now we're going to continue with Tyler's story. We ended off before the break, kind of where you landed now at Yaskawa Robotics. What's the full name of the companies?
Yaskawa Moto Man Robotics.
So Yaskawa Moto Man Robotics. Now I've seen and I've actually gotten priced and looked at many Yaskawa robots over the years because they have usually a pretty good price point. They have a lot of variation in sizes and types of robots, which some companies don't have. Um, when you got hired there, what was the role you got hired in as?
Yeah, so I was hired as a design specialist, specifically a mechanical design specialist. But because Yaskawa runs such a lean ship in Canada, uh, it kind of overlapped with a few different roles. So yes, I do the mechanical design, but I also do a lot of quoting and concept work on our custom welding cells
Hmm.
and systems. And then I also do some simulation work as well.
Awesome. And now you service the Ontario market, or do you service Canada or Western Canada?
Yeah, so our office takes care of all of Canada. My role specifically takes care of all of Canada. Our sales reps are a little bit more regional, but our engineering team takes care of all across Canada.
All right, so now I got some robot questions for you. They're very specific, and I hope you can answer these for me. All right.
Okay.
When you guys are at your work and you got your robots and you're figuring out designs and you're getting interfaces set up, how much of the time are you guys making them do stupid things?
um, Percentage of time, I would probably say about 30%.
That sounds
There's
fair.
always,
Yeah.
yeah,
And there's a lot
there's
to
always
learn.
those, yeah, for sure. There's always that downtime that you have in the office where you just walk out to the robots that we have in the back for demos and for trials and testing and everything. And you're like, I wonder if a robot could do this. I wonder if I could weld this to this.
Hmm.
And you just kind of try the things that don't really make sense or might not be traditional, but they're interesting to try.
Like I mean, we got a fairly large Miller robot. It's a ABB Miller, and then for welding, and then we have a whole bunch of smaller robots for where they just learn for manipulation and stuff like that and
Mhm.
coding. But literally every student sits down and goes, "Okay, yeah, this is what you do." Then it'll be one of two things: either it's going to write their name, everyone wants it to write their name, or number
Mhm.
two, it's going to give somebody the finger or something like that. Like it's going to be one of these basic simple commands. I mean, a wave is usually a go-to, but
Mhm.
I figure that like a person like yourself, where you're sitting in a room full of robots and you got a lot of time, you probably can get pretty like secret handshakes. Can they do anything cool like that?
We have a video where there's two robots using samurai swords, and
Oh, okay.
they're dancing and they're kind of like doing a little bit of
Choreographed.
sword work.
Yeah.
Yeah, choreographed. And then actually, out of our Mississauga office, we had a robot working as like those claw machines.
Oh,
So you
yeah.
could pick
Yeah.
up a PlayStation controller, move it around to pick up your toy, and then press a button to have it close the gripper, pick it back up, and move it back and drop off in a location. So that was a nice little trade show demo that we got set up.
Awesome. Now, the robot spectrum at Yaskawa is pretty large. Um, do you see a big push into welding robotics as opposed to manufacturing robots, which are mainly material handling, or what do you find yourself working with more?
Personally, I'm more devoted to the welding side. I have a counterpart who works more on the material handling and material removal side, so the grinding, buffing, that kind of stuff. Um, But in terms of us as a company, our niche is definitely welding.
Hmm.
We started as a division of Hobart, so we have that really strong welding background. So it really helped us kind of find that niche and develop a lot of our software capabilities and interfaces related to the different welding power sources.
So you get to play with a lot of welding. Now, your have you improved yourself as a welder, learning to program the robots? Because they always say behind every good welding robot, there's a good welder.
Yeah, I would say from a technical standpoint, my welding has improved because I've got to deal with a lot of unique alloys and a lot of situations where I might not have been exposed to in college. In terms of could I pick up a MIG gun and pass a CWB test? Probably not. It's
Oh,
been a
come
while
on.
since I've had to
I
do
bet
any
you could.
manual welding.
I bet you could do it. And you know what? If you didn't do it and you failed, you'll go back to work and all the robots will be laughing at you.
Yeah, there we go. Exactly.
Okay, next question I got about robots is about I just read an article actually this morning that came out. I think it was a Globe and Mail, where they did a study and they found that companies that invest into robotic welding actually have more welders on staff than companies that don't. And I think that's a large misconception that I've been trying to push away for a long time, but it keeps coming back that robots that weld kill welding jobs. I don't believe that for a number of reasons, and I know the data that supports it. But from your point of view, what would you say about that statement that welding robots kill welding jobs?
Yeah, I mean, it's definitely different for every industry and every situation. I would say the vast majority of applications that I work on, the robots are going in to improve production volumes. If a company is getting orders that they just can't fill because they can't find enough welders or they just can't push the production out the door, oftentimes they'll turn to automation to increase volumes. And because you now have this piece of automation that you have to feed with either upstream or keep pace with on downstream operations, it often ends up having more people and more labor involved just to be able to feed and to be able to get these things out the door, whatever the company is producing.
Yeah, I agree with that. And also, I mean, now robots have changed quite a bit. Initially, there was always a lot of quality control issues with robots because they were so fast. But there
Mm-hmm.
was always, issues with seam tracking, with fit up, proper jigging systems, and positioners, and what do they call fixtures. Um,
Mm-hmm.
Now that's getting better. Robots are getting much more intuitive now, right?
Yeah, definitely. There's a lot of technology available that we can add on to systems. Like you said, seam finding, so we can actually just do like a touch sensing. So what that does is we induce a current into the welding wire and we physically run it into the part. And when we touch it, we find that offset from where we think it should be and then apply that to the path. We do have seam tracking technologies, whether it's through the arc, um, using the characteristics of a CV power source where we know that the voltage is going to stay the same, but as we increase or decrease the stick out, our amperage is going to change.
Yeah.
So we actually weave the robot across that, say, fillet weld. And as we're in the root of the weld, we're going to have a longer stick out. As we move out of the root, we're going to have shorter stick outs. And using that change in amperage, we're able to keep the robot right in the middle of the seam. And then even a step further, we can introduce laser seam tracking and cameras to continue to increase the technology. So it's definitely become a lot less of an issue when customers have bad part fit up and inconsistent parts. It's
Hmm.
not as big a barrier to introducing automation as it used to be.
Yeah, I know some of the new technology out is well, it's honestly, it's kind of funny. And I hope you agree with me, and I'm not just talking BS here, but I feel like we talk about robots like they're new, but they're not. Robots have been around 30 years in the manufacturing sector. We're just not where we should be in the robotics world. I think in Canada, I think we've kind of in a lot of ways ignored it. I think the automotive sector brought a lot of robotics and automation into Ontario, but it hasn't really gotten big outside of Ontario as much yet. But it's something that's when I say, there's new robots out, in my mind, that's really like still 5 years old, 7 years old. I mean, our
Mm-hmm.
welding robot, I think, is 3 or 4 years old, and it has lots of the features that you are talking about. I mean, I could put a plate in at a 45-degree angle, and it'll figure that out and run it uphill without me having to change anything. And that's
Exactly.
that's something that I remember working at Brant, oh God, 12, 13 years ago, and they got their first Lincoln robot, which is like the first robot every company buys. And it was this massive, massive, like 10-ton fixtured robot that we had so many problems with because it's just ignorance. We don't know. Right?
Hmm.
We're learning as we go, and those now it's becoming much easier to deal with.
Hmm.
All right. So third question. Okay.
Hmm.
Do you guys make cobots?
We do make cobots. We have two now. So we have the HC10, which is a 10 kilogram collaborative robot, and then we have the HC20 that is newly released, and that's a 20 kilogram collaborative robot.
All right. So for the listeners that don't know what a cobot is, because I think they're super neat, I got to play with a few last year, and I was hoping that you guys had some on your, because I didn't see them at your booth last year. And tell the listeners what's the difference between a cobot and a robot.
Yeah, so collaborative robots, in a nutshell, are designed to be safe for human operators to be around. Generally, industrial robots need a lot of guarding, whether that's fences, area scanners, light curtains, whatever that ends up being, or a combination of, to make sure that people aren't in the operating zone of the robot because the robot doesn't know that you're there and it's just going to keep doing its job. And if it runs through you, it's never really going to know that it ran through you. So it can be a pretty dangerous situation. Collaborative robots, they actually use force sensing. So if they actually run into something or if there's too much force on them for whatever reason, um, they will actually stop, and then you have the ability to kind of clear that fault and then continue moving on. So from a safety standpoint, you can work right beside them and they can do a variety of different applications like that.
Now, I find that having the user be immediately beside the robot in a collaborative situation, it also changes the way the machine can be coded or programmed because now you can physically grab the robot and run it through manually a set of points, and then the robot will program itself along those points and be able to mimic you. I find that to be a huge step forward. What do you think about all these new technologies with the cobot?
Yeah, hand guiding that drag the robot through the path that you're talking about. It's very nice for people who aren't incredibly technologically savvy.
Hmm.
So if you take your guy who's been welding for 20 years and he is the best welder, he knows exactly the right parameters and travel speeds and torch angles and everything for that particular product, and you say go grab that robot, press that button, move it around, and the robot's programmed, put in your parameters, it's a lot easier to take somebody like that instead of having to go up to the engineering office and get the guy who's been running your CAD system or is very high level capable with technology to start running that robot system. So it's definitely opening a different area of robot programmers and allowing different skill sets to be utilized better.
I think that it's very valuable what you just said about opening up new doors because a lot of welders that have been in the field a while, and maybe are not comfortable around robots, feel that I guess unease when they're around a robot, being like, well, not only is this thing gonna be able to weld faster and cleaner than me, um, I also am not even allowed to play with it. I'm not even allowed to go in there and see what it's doing. I'm not going to be a part of the process. There's going to be somebody in an office that has a bunch of training that I've never met before that's going to come down and run this thing. And I'm basically excluded from the process. And we really don't want those divisions in the trades, right? We don't want to create the you can play with that or you can't play with that. And I find
Mhm.
that cobots kind of help bridge that gap a little bit, even as a training tool. Because I know that when I got to the guys, when I got told, just grab it, move it to where you think it should go, and it would, and I was like, what? That's it? And they're like, yeah. And I was like, from an automation point of view, that's probably got very little value. But in terms of a connection to the audience point of view, or having a person who's a welder understand the machinery concept, I thought it was very valuable.
Yeah, definitely. One of the big things that we really try and stress is that you have to have that connection from a variety of different people. You can't have your engineer who's been sitting up in the office try and run your robot because chances are he doesn't really know much about welding. If he knows anything about welding, he might come from an entirely different background. So to have all of the different skill sets involved in a welding system is really important. And we really try and stress that. You need to be training the guy who's been welding this part for 20 years on how to use the robot just as much as you need to be training the engineer who might be designing the CAD that goes into this system or the parts. They both need to be trained and they both need to be part of the programming process because they're both bringing different skills um, and information to the table.
For sure. I've seen that process play out dozens of times now, and it's almost like beautiful art when it starts to happen. Everything starts coming together, and then you see the guys on the floor start having ideas, being like, well, this thing could probably do that part. That one over there that we literally do 6,000 of those. Why isn't it doing that one? And then our good guys aren't pulled off jobs to go make those 6,000 stupid brackets. The robot can just do those. And then you see the floor kind of get into it and be like, "Oh, what jobs could this do that maybe we don't even like doing? We're complaining about it taking our job. Well, instead of it taking our jobs, why don't we give it the jobs that we don't want?" That opens up the floor for production that square footage is money. That moves that job off the floor and into the robot cell, and it allows the welder. You got Sheila welding over there, and she now can be in charge of something else and doing a more complex project that the robot is not able to handle.
Absolutely. It opens up a lot of opportunities for companies who tend to have a lot of mix. If they have one or two contracts that are their high runners, high volume products, throw those onto the robot, and then you can keep all of your skilled welders welding the more complicated one-offs, small batches that aren't really well suited for robots. I mean, you have to have a certain amount of volume before it justifies itself to put it on the robot because there is that time investment up front to program the robot.
Yeah.
So it definitely allows companies to take on more contracts and bid on more jobs because now they have the production welders and the skilled people that can be doing these different jobs. And then they still have the production capacity from the robot to take on higher volumes. So it really diversifies companies for sure.
Yeah, I know that one of the things that I've learned about robots is when they talk about the production of robots or the production pace of a robot, they don't necessarily mean the number of parts, but could also even just be deposition rate. Because
Mm-hmm.
robots are really good at not getting bored, and they can run multi-pass or multiple pass, deep bevels, thick plating welds all day long without ever getting too hot. The hands don't burn, and those are welds that generally a user struggles with, especially when monitoring heat inputs and joules. That's data that the robot can actually even take at the same time, right?
Yeah, absolutely. There's a lot of different sensors that we can add on to systems, especially when we're concerned about interpass temperatures and preheats to make sure that the robot is absolutely never welding when we're below our preheat temperature or we're not exceeding our interpass temperatures. So there's definitely a lot of controls that we can add on to these critical welding applications where the robot is really well suited for. It can monitor everything. It can make sure it can do variable pauses in between passes to make sure that we're cooling the part off enough, or we're not starting a weld when we're too cool. Definitely.
What are you guys doing now during this COVID era, in terms of getting your message out there or getting, the robot in front of students or people? I mean, you're very limited now as for movement, and probably tours are off right now. What are you guys doing to combat that?
Yeah, so we've been trying to start up some webinar series. Our US office plays a huge part in that. They have a very large marketing team, and a lot of our project and product managers are down there. They've really been ramping up on the webinar side to try and get this information out, even while we're continuing and our head office in Japan is continuing to develop new products and new robots and new functions. We still need to get that information out. So we've really been ramping up the webinar side, doing some informational videos, stuff like that, as
You,
much online as we can.
yeah, and you guys also have a sim product that you guys can sell as well, right?
Yeah, we have a software called Moto Sim. So that allows customers to kind of program the robot on their computer, um, look at the process before they throw it out onto the floor. And even some of what we call our power users will actually build their own cell in Moto Sim and say, okay, here, Tyler, this is exactly what I want. Just
Make it
take
happen.
it and give me the products that I need to do it.
Yeah, that's awesome. Um, all right, we're almost coming up at the end of the show. This went super fast. I love robotics. I'll tell you a little story about Max. When I was in grade 6, I won my elementary school, high school science, or my elementary school science fair because I built a robot out of like servos and gears, and I had a VIC 20 computer. That's a long time ago. It's a 20K computer with a tape line to it, and I could program steps and it could draw like shapes. And I remember being like, I'm gonna be a robotics engineer someday. That was my dream as a kid. It didn't work out that way. I didn't really grow up in a place where that was I had accessibility to that type of education, but it's always fascinated me, and I love where it's going. Now, in my mind, I have a vision of where robotics can go, both with welding and manufacturing and at large. Now, you're 24, working for a robotics company, where you get to see a lot cooler stuff than I get to see. What's your vision? Where do you see 5, 10, 50 years where robots are going to go? How fast is this going forward, or is it not moving that quick, or are things going to get crazy, or what do you think?
I think robotics is so diverse that every industry is moving at its own pace. Some are moving faster than others. But welding has so many functions within it. Like there's so many different things that you have to consider in a welding process. It's not as simple as picking up a part and putting it somewhere else. So there's definitely, I think it's going to be a huge advancement with this Industry 4.0 of data monitoring and data collection and traceability. I think that's really the next step in robotics is this widespread idea of knowing exactly how long what robot welded on what part, what was the welding characteristics, what was my amperage throughout the entire process, and using that data to kind of say, okay, maybe I need to do extra inspection on this one because maybe I was outside of my ideal range, or this one was perfectly within my range, so we'll just let that one keep going and just do a quick visual on it. So I think this Industry 4.0 is definitely going to pick up. And the idea of this data collection, data monitoring, and really taking that data and using it to drive downstream processes is really going to be a big thing in the next little while.
Yeah, the technology 4.0 is a precursor to what I think all people are gunning for in computation and automation is some form of a simple AI, right? Because that's really
Mm-hmm.
where you're building the foundation for AI is with proper metrics and data collection. Once you have enough data and metrics set up properly, now you can start doing automation where self-correction can start to happen. That's kind of like the end game, right? Like I think that's where you can buy a robot and it participates in the production stream or the value stream of the product instead of being just a passive, tool. It can start being like, no. I think if I do this first, it'll be faster. I think that would be cool. Are we getting there?
Yeah, definitely. I haven't seen it start to creep into the welding industry yet, but in terms of material handling, there's definitely vision systems used for random bin picking,
Hmm.
where they have started incorporating AI and it's used in a production setting already. And the robot basically it sees the part and it can adapt and figure out what the best orientation of the gripper is to pick up that product out of this bin, how it needs to kind of shake itself on the way out to get free from the other products in the bin. So it's definitely coming. I'm interested to see what people do with it in the welding industry, but AI is there. AI is a very powerful tool that I'm sure will be leveraged more and more in the automation industry moving forward.
Awesome. That's super interesting. Are you going to be heading out to any of the big fairs in 2021 if everything comes back? Are you guys going to be at CanWeld and then FabTech?
That's the plan. Assuming everything comes back
Hmm.
and we start to lift some of these restrictions and we can safely gather
Yeah.
to continue to share information, technology, um, build the community that we have in the welding industry. As soon as we can get there, Yaskawa will be back out there at the shows and is as big a booth as we possibly can.
That's awesome. I'm gonna have to get you guys in for one of our CWB Association little drop-in zooms that we do with college students. So we should hook you guys up for maybe some live demonstrations from your testing facility. That'd be pretty cool.
Yeah, that sounds great.
All right, well, we're at the end of the show here, Tyler. That was super fascinating, super fun. I hope all the people listening enjoyed that. If you guys have questions for Tyler, when the show comes out, his information will be included in the podcast. Make sure you download and share these as much as you can. Yeah, all the support that we're getting through the community has been fantastic. Hopefully, we can keep this growing. I know it's going to be lots and lots of cool things coming up. Tyler, thank you for coming on the show.
Absolutely. Thanks for having me. I just wanted to quickly, for anybody that's listening in the Kitchener area, be sure to check out our Kitchener chapter CWB events and Instagram pages, just so we can all get connected and continue to grow the community.
Yeah, it's I know that you're a part of the CWB Association as well, and we're all out here volunteering our time, trying to do the best we can, and it's very valuable. So thanks for that too, Tyler.
Absolutely.
All
Happy
right,
to do it.
cool. Well, thanks a lot, and make sure you guys stay tuned for our weekly podcast. I'm Max and with Tyler, and take care.
We hope you enjoyed the show.
You've been listening to the CWB Association Welding Podcast with Max Ceron. If you enjoyed what you heard today, rate our podcast and visit us at cwbassociation.org to learn more. Feel free to contact us if you have any questions or suggestions on what you'd like to learn about in the future. Produced by the CWB Group and presented by Max Ceron. This podcast serves to educate and connect the welding community. Please subscribe, and thank you for listening.